Hi, I'm Paul Battaglia, and this is section 9.6, Counting Principles. I'm joined by Gabe and Brittany today, and I know you're probably wondering why we have these titles here, which we'll get to in a minute, but we're really trying to give you an idea of how maybe you can structure the lesson for 9.6, and Brittany, I think a good place for us to start off is probably the fundamental counting principle. So talk to us a little bit about how you go through that with your students.
So before even mentioning the fundamental counting principle, I like to just give my students an example, say, all right, well, let's say we have 5 types of ice cream.
Okay.
And then we have 3 toppings.
Okay.
And then we have 2 different syrups.
Okay.
Well, how many sundaes can we make out of that? And so that gets them thinking about the fundamental counting principle without even knowing it. And then I'll actually define it for them.
Right.
And then I'll say, well, what if order matters? What if we have repetition?
Right.
Then where do we go from here?
Great. And I think, Gabe, I know you have a really neat activity that you do with students, because I think, like all of us here, you find that your students actually struggle with the differences between combinations and permutations.
So to introduce the idea of combinations to my students, I like to give them I like to have 3 envelopes with no markings on the outside and tell them inside the envelopes there's a prize. And while doing combinations, they'll be the same prize. So I'll tell them, I don't know, $100, $1, just something. Just fake money.
Right, sure.
So what I'll do is I'll walk around the classroom and I'll give one student the first envelope, another student the second envelope, and another student the third envelope. And I'll say, you know what, I don't really like you 3. I'm gonna choose 3 other students. So I'll take the envelopes back and I'll say, oh, well, I'll give the first envelope to you, second envelope to you, and the third envelope to you. And as I'm going about this, we'll have conversations about, well, how many different ways out of 20, 30 students can I choose 3 winners?
Right.
And from here, well, I'll sort of introduce this idea of what a combination is and really emphasize that the order that I pass these envelopes out doesn't really matter. It doesn't matter if I give one to Jimmy and then Steve, or Steve and then Jimmy.
Right.
They both end up with the same amount of money. But then I come back and I have 3 envelopes. This time, one has $1 million inside of it, one has $100, and one has $1.
Right.
So here I walk around and I'll just choose 3 students at random, pass out the envelopes, pull the same trick where I say, I don't really like you, let's give them back. And I'll pass it out to 3 different students. And here what I'm showing is that, well, the order really does matter.
Right, of course.
And the number of ways that I can pass these out to the students is much different than it was where the order was the same. Because if I give one student $1 million and another student $1, it really mattered which order I passed out those 2 envelopes.
Right.
So here's how I sort of lay the foundation for permutations and address the differences between a permutation and a combination.
And I think what's important from a teacher's perspective is, I like to use the word significance, because what Gabe was doing there was actually displaying the significance and the significant difference between just everybody winning $100, or those 3 people, versus those 3 people winning $1 million versus $100 versus $1. And that's really important for you to portray to your students. So let's just suppose that maybe through that example, you kind of get through them a little bit, but you'd like to maybe kind of spice it up and make it a little bit more kinesthetic. So hence the titles we have here. So same idea as Gabe, really nothing majorly different. But the idea here is to give students an understanding that, okay, if there were 3 of you here, and you can pick any 3 students you like and say, let's come on up to the front of the class here and let's talk about the way we arrange you. Let's say we're going to take a photo of you guys, and we talk about whether or not the photo is considered different or the same. And so if you took a photo right now of us, there's some significance behind where we're standing. Brittany right now is acting as the president. Gabe is acting as the secretary. I'm acting as the vice president. So, again, at first glance, it looks like, okay, fine. But watch what happens when we switch, right? So let's just suppose that Brittany and Gabe switch spots. Okay, so you ask your students, all right, is it different? Is the photograph any different? And if the answer is, well, no, because all 3 people are in the photograph, they're kind of missing the point. It's vastly different. Now the president used to be Brittany. It's not anymore. Now it's Gabe. So it's really, really a nice little thing just to show people just the significance of permutations versus combinations. Now, Brittany, talk to us briefly about maybe some calculator issues that come up.
All right, so a lot of students have different calculators, and some of the students don't know how to know the difference between permutation and combination buttons.
Right.
And so I like to give my students a lot of examples, and I'll go around and actually look at each of theirs and see just if they know how to input one or the other, or both of them. So that they get more familiar with their own calculator, and so that when an exam or homework comes up, they're
not a
comfortable
problem,
with
right?
it. Yeah.
And I think it's so important because I know my students, they're sharing calculators, they forget their calculator using somebody else's calculator. So, the buttons, while they may look the same, they might be hidden in different menus. So Brittany makes a very good point there. I hope these tips have been helpful for you and you find much success in section 9.6.